Okay, we got the 2U-Try problems. This is the first of a few for your attendance points. Let's start over here. Index for both of these is 2. We're looking for one of two equal parts. So we remember that this is a 2. We see that the power matches the index. If the power matches the index, we will take out the base. Get in the habit of doing that, but also then realize, does it have an odd index or an even index? Is 2 even or odd? Well, 2 is even. If it's even, we need to ensure that we apply the absolute value. Now this is different than one we had before where we just had the z we're taking out. When we apply the absolute value, we want to apply it around the entire algebraic expression that would be taken out, whatever that base would be. Okay, we don't want to just, in this case, we don't want to just apply it to the x. We want to apply it to the x minus 2. That's different from the last one because in this case, the negative 2, the minus 2, that 2 is a term. The one we had before with the 49z, or the 7 squared, the 7 that we took out was a factor. There is a difference. So if you have this, that would only be correct if that was a 3 and that was a 3 for an odd index. We have to ensure that the expression will be positive. So we have to ensure, because that's even, we apply the absolute value around the entire expression. If that was a 4 and that was a 4, we do the same thing. If it's a 3 and a 3, 5 and 5, if those are odd, we do not worry about the absolute value. Okay? If we go to this one, many of you say, well, that's just going to be negative 5. Well, when we look at this, remember, we've got 5 times 5. That gets us 25. But that's not what we have. And then some would say, well, it's negative 5 times negative 5. But that still only gets us to 25. When we look at this, there is no one of two equal parts. There's no number times itself that will get us to negative 25. So what we see this is an even index. If we see an even index, a 2, a 4, etc., and we have a negative radicand, we will realize that there is no one of two equal parts. So we have a no real solution. Now some of you will progress and you're going to want to say a specific answer, and I will tell you not yet. Okay? There are some of you that will have already seen this information. I'm teaching for those that may not have. Okay, so on these items, your other answer that we'll progress to, we'll get there. We're not there yet. So what I'm looking for here is no real solution. I will not accept the other answer. I'm not going to tell you what that is yet. So if I have an even index, 2, 4, etc., and a negative radicand, we have a no real solution. There's no one of two equal parts that will get us there. Sometimes you may have to multiply this out, if it's in a set of parentheses or not, to see if it's a positive or negative. Okay? This is another part of the notes. This here is different than what we've had before. All the stuff we've had before have been factors inside. So we had that 49 times z squared. We had the 25 times x squared, or whatever it was. Here I have pluses. What we have to remember is that we want to remove factors. We want to take factors out. So when we see something like this, we don't want to just say, hey, that power matches that index, take out that x. Hey, we already saw 49. We can say that's 7 squared, take out that 7, and then just leave this inside the radical. When we see something like this, what we want to try to do, and these ones will be factorable. Down the line you may get ones that are not, and you go through the process. But the ones I will give you, when we have this, we want to try to get this to match this format. Because once it is in like this will match here, and we can do what we just did there. So this is where we incorporate our factoring skills that you should have been working on. So this is a 1. So we look, because this is 1, we look to see what factors of 49 will add to 14. So when I look at this, I know that when I factor this, I'll get x is the only way to get x squared, and positive 7. 7 times 7 is 49. 7 plus 7 is 14. Now this and this are almost exactly the same. We just had an extra step to get there. Look to factor anything that looks like this. Once we get here, then we realize this is a 2. That power matches the index, take out the base. But I need to ensure that the expression will be positive. Because it's an even index, I apply the absolute value around the expression. Okay. Our next clip, what we'll be doing is we will be evaluating functions, and that will tie back to the items we've been doing with the functions. I will talk about graphing a little bit in there, but we will not be required to for that. So stay tuned for the next clip.